Okay. Well, hello, everyone. This is Rebecca Dallin with the City of Oklahoma City Stormwater Quality and the Central Oklahoma Stormwater Alliance, or COSWA. I'd like to officially welcome everyone to this special training event. If anyone is interested in receiving a certificate of attendance for this training, please send me an email to request that. I will need your email address to be able to send you a certificate, so please don't request these in chat, but I will be placing my email address into chat, so that way it's handy for everyone. If you have any questions about the certificates or haven't received one within a couple of days after the webinar, feel free to email me about that as well. We would ask that everyone keeps themselves muted during their presentation. If you have any questions, just type those into chat and we will definitely have time at the end for questions. Today we'll be hearing from Sirish Tuladhar of Haynes Geocomponents. He'll be sharing information on his presentation titled Erosion and Sediment Control Solutions. Sirish is a technical sales engineer at Haynes Geocomponents. He has a Bachelor of Science degree in civil engineering from Louisiana Tech University. He thrives on providing advanced geotechnical solutions, leveraging over 15 years of dedicated experience in the industry. As a technical sales engineer, he specializes in highways, erosion and sediment control, and stormwater management, ensuring that projects are supported by the most effective applications and solutions. With a strong foundation in geotechnical engineering and a proven track record in construction, his role involves collaborating closely with clients to tailor solutions that meet their unique needs. His objective is to be on the job site with the contractor to ensure that installations are running smoothly and to lend a hand when a second opinion is needed. His proficiency in languages such as English, Hindi, Spanish, and Nepali enhance his ability to engage with a diverse clientele, fostering robust relationships and partnerships in the geotechnical field. All right, I'm going to stop sharing, and Sirish, feel free to share your slides if you would. Thank you for being willing to share this information with us today.
No problem. Sure. Let me do that. Can you see my screen?
Mm-hmm.
Perfect. I'll share this one. Looking good?
Yep, perfect.
Let me just close the door real quick. Sorry. Our office gets very loud as the days goes by. Thank you, Rebecca, for a great introduction, right? And thank you for Central Oklahoma Stormwater Alliance for this opportunity to present you. The topic today will be optimizing sediment basin, but I'll be covering most of the product that Haynes cover, and we'll be talking about different ways to optimize the sediment basin. Before I do that, I'm Sirish Tuladhar. I'm the technical sales engineer for the North Texas and the Oklahoma area as well. And we have Tate Lamb. Tate, do you want to say something? He's our Oklahoma regional sales manager as well. Do you want to say anything, Tate?
I'm happy to be here, Sirish. Thanks for taking the time to do this. Rebecca, thanks for bringing us in, as we're kind of a new affiliate member of this organization, and hopefully this will be the first time many of you probably are meeting us or seeing us, but maybe more to come. So thanks everyone for being here.
Awesome. Well, a little background on me. I graduated from Louisiana Tech University on 2011. I did my bachelor's and master's in civil engineering, and since then I've been working in the geotechnical industry. I started with Duedex System International, which dealt with mostly below ground structures, but now I'm with Haynes. It's been this is my 8th year with Haynes, doing the erosion control, sediment control products, and I'm one of the technical sales rep for the company. Before I do that, let me just introduce about Haynes, right? We are one of the largest distributor of erosion control, stormwater products, and sediment control products as well. We have about like 45 plus locations all over the North America and also 5 in Canada. And like in Texas, we have 5 locations, and now I'm just covering this Oklahoma location we have in Oklahoma City. Where before I do that, Hanes product is categorized into 3 different. We have the geosynthetic, which is mostly the geogrid, geotextile, gabions, geomembranes, and also erosion control. We carry all kind of light, medium, hard armor products like Fleximat. We also carry products from Solmax and light medium product like Pyromat and all those stuff. As far as sediment control, we carry all kinds of silt fence, wattles, anything you need. As far as stormwater, we have SD pipe, CMP pipe, and we also do quite a lot of underground retention system and detention system as well. So this is what I'm going to be focusing on, introduction to sediment basin trap. This is getting really common now. It started in the North and the South Carolina, Georgia, Alabama, Indiana. They commonly use the sediment basin, but it's slowly moving to in this side of the central South, like Texas, Oklahoma, and you see quite a lot of this in different projects. And I get this sediment basin, like especially in Texas, like I see this every week, like 3 or 4 times. Like I have to design skimmers based on the sediment basins. So it's getting quite a popular. And today, this series will be trying to educate, like a lot of the engineers or contractor, whoever is there to educate about sediment basin, how important it is, like in capturing the sediment. So what is a sediment basin? A sediment basin is a temporary area where sediment ladder runoff is trapped or detained during construction. Basically, you're digging a hole and water flows in the hole through the pipe or channels, and the dirt settles over time, and water is discharged through a pipe in a cleaner fashion. So it might be temporary or permanent sediment basin. You can see on the pictures, the plan view, where you have the water is coming through a pipe or channel, and it's first going through the turbulent zone, and then it's gonna go through where most of the sediments settles in the laminar zone, and then it goes throughout. The cleaner water washes out through the outlet. So some of the reason why we use sediment basin, right? First reason would be like you see on this picture, we sell all these products. We carry the silt fans, but they are not the strongest product, to capture the sediment, right? You see the picture on the right, the sediment, the silt fence is about to fall down, right? I mean, it lasts about like 3 to 4, 6 months. It's not as strong. And also, you see the inlet protection down there. It's something you want to use in the job site to capture before it enters, right? It's something you do at the very end. So it's not a great. Some of the reason why we want to use sediment basins. You see on the picture on the left, the milk crate. I don't know what project was that, who decided to use that, but it's not a way to capture the sediment, right? So I took this course, right? This is a great course. Any engineers or contractor this is a designing and reviewing course on sediment and erosion control. On that course, this author, Jared Phil, who actually was sorry that he passed away. I think it was like 4 or 5 months ago. He was one of the pioneer on this CPEC certification. And on that book, he says the only BMP that can create optimal condition for removing suspended particles out of runoff waters are sediment basins and traps, also known as sediment containment system. This design structures have the potential to remove 75% or more of suspended solid found in runoff water. So today we're going to talk about how to get that 90 to 95% of capturing the sediment by using different products that Hanes carry, or that's the different product we have in the market. So some of the reason why we use sediment basin, right? I mean, you can see that DEQ, Department of Environmental Quality in Oklahoma, and also Texas Commissions of Environment, for common drain solution that serve an area with 10 or more acres disturbed at one time, it's to size to contain a 2-year 24-hour EML, you may want to use a sediment basin is required, right? So but in Texas, we use sediment basin even in 5 acres. It's a pretty, I cover a pretty large, like from Dallas to Fort Worth area to almost to El Paso. And especially in Dallas, it's 10 acres. And then you go to Fort Worth is more like 5 acres disturbed. You're going to need a sediment basin, right? The same thing with Oklahoma City as well. So why are sediment basin installed, right? Typically, they are one of the first thing installed in project, installed before any loss clearing and grading is done, and can be installed by any general contractor, grading contractor, clearing and grubbing contractor, and also erosion control. This is the first thing you want to install, right? Whenever you're installing the silt fence, you want to it goes along with the silt fence, right? And it's a great application to capture the sediment. Before I do that, let's see how the sediment basin works, right? You see the picture on the left, right? It's orange juice ready to be, it's in the fridge and ready to be drunk, right? The one on the right side, like suppose you're coming back from a vacation and in 5 or 6 days you come back and you look at the fridge, you see all the pulp in that orange juice settle down, right? And that's a similar way, the sediment basin works as well. Basically, it's the drag force, right? I mean, there's different particles in water. They settle in different time. Next, I'll talk in more in detail in the next slide. So that's how the sediment basin works as well. Bigger particles like gravel has a bigger drag force. That's why it settles faster compared to other particles like silt and clay. It takes about like 10 weeks or, maybe even silt, like it takes about 10 minutes. So this is a great slide, right? I mean, before we talk about sediment basin, you want to know how different particles settles over time, right? You have the bigger particles like gravel, which takes about 0.1 second, and we have coarse sand, fine sand, which is about 1 second, 10 second, and then we have silt and clay, which takes about 10 minutes or 10 weeks, and then we have particles like colloids, which takes indefinite time. It never settles. It might take even 10 to 15 years to settle some of those colloid particles, right? So we're going to talk more in this presentation about flocculant as well. I have this soil water that I brought in from Howey, Texas, right? And I'll show you how some of these particles settle within, like colloid particles, like how it settles within about like 10 to 15 seconds, like by adding some of these polymers. I'll talk about more in the very last slide. So basically, this is how the drainage plans work. Right? Anybody who is an engineer who design, sediment basins, right, knows how the basic plans look like. You see on this basic plan, the ponds sediment basin on the right side is bigger compared to the sediment basin on the left side. The right side, you are actually it's 5.6 acres disturbed, so the sediment basin is a little bigger, right? Just an example to show you how this, the drainage plan looks for the sediment basin. So now we're going to talk about different components. We talked about just adding a sediment basin, you can get up to 75%, right? Now we're going to talk about different sediment basin components that you can use, right, to get that 90 to 95% capture of sediment. First would be inlet and forebays, right? I mean, you don't see this quite a lot in Oklahoma or Texas or, a rock fill wire, also called check dam, right? Or a gave-in forebay. It's basically a first barrier to really slow the water down, right? It won't cost you a lot. I mean, it's very cheap, right? I mean, using this can get you up to 90% of sediment capture, right? This is something very cheap, right? I mean, if you use this, it's very good to capture sediment. Next would be our newest product, right? I mean, this is a newest product we introduced last year, Flexiberm, really good check dam structure. It's actually reusable, right? I mean, you can reuse this Flexiberm again and again. We've done quite a lot of projects in Texas. We haven't done one in Oklahoma, but soon we will. I'll show you a quick what this product is. Basically, if anybody's familiar with FlexiMat, it's actually a concrete block wrapped, right, and we put a Curlix unit in the middle, right. It's a great way to slow the water down, capture the sediment. It's a very cheaper than the regular check dams or rock berms as well. And another thing is like they are not, those rock berms cannot be used again. This one you can reuse again and again. So really quick videos to show you that we did a project in Salina, Texas. You can see the water flowing through it. And at the back, you can see all the ponding and sediment is settling over time up there. Next would be geotextile fabric, right? It's another, you can actually basically get with $500, you can get a 15 feet by 300, right? It's another product you can use under the riprap, right? I mean, you're already building a sediment basin. I mean, if you don't use this fabric, what happens is like, the water is gonna, just erode that whole thing and, and you'll have more sediment collecting in there. So it's just another product you can use in sediment basin, geotextile fabric, right? Only $500 to optimize the sediment basin. Next would be core baffles, right? I mean, you see quite a lot of this in slowly getting in Texas as well, right? It's basically if anybody's not familiar with coir, right? It comes from coconut tree, coconut husk. It's a great erosion control product. What you do in the sediment basin is like, you have three bays, bay 1, bay 2, and bay 3, right? Basically, you drill a 4 feet post, right? Every 3 feet horizontally, and then you put a core mat around it and put a 9-gauge wire wrapped around it with a T-post and drape the core mat over the wire. It's a great tool to slow down the water, and it sprays. Basically, like especially in urban university, they have done a study where study of capture of different size microns, like biggest in the bay 1 and smallest in bay 2 and bay 3. Very inexpensive, right? I mean, it can really greatly increase the chance of capturing the sediment. Quick picture to show you what's baffle function is. And we have all this details as well, like, we provide engineers if they need some kind of sediment basin, details with the core baffles and everything. We do have that as well to provide that. Next would be sill fence, right? It's another not that expensive, right? Product, another option. Basically, but it's woven sill fence, right? It's impervious baffles. What as you see in this picture, right? What happens is like here is water fills in the first bay, and you see a low weir at the very end, right? Low weir. From there, when the water fills up, the water jumps to the other weir, right? And basically, and then it goes to the second baffle, right? And then as time passes, right? I mean, the dirt settles down, and the cleaner water. But basically, what it's doing is like it's actually basically lengthening and buying the time, right? Going through the weir, right? It sells on the first weir and then goes to the second weir. It's another cheap product, right? I mean, but it's like it's impervious baffle, so it's another way to optimize the sediment basin. Next would be erosion control blankets, right? I mean, Haynes carry all kinds of erosion control. We have light. We also partner with American Excelsior, which is our great partner. I mean, we do quite a lot of those erosion Curlex and the little robust recyclex and also Trinet recyclers. We do carry all kinds of erosion control blankets. Basically, what I'm trying to do is you're already digging a sediment basin, right? Right after, you never know in Texas or Oklahoma, there's always 60. It rains about especially in my Dallas area where I live, it rains about 65 to 80 days per year, right? So when you're building a sediment basin, you want to protect the slope, right? As soon as the basin is done, you want to protect it with some erosion control blanket, right? What if you don't do that? What happens is like everything, all the sediment is going to get collected, right? You're already building a basin, so another cheap, application that you can use, that you can optimize the sediment base. Next would be skimmers. I mean, I'm like it's another great product. It's basically a floating device. We'll talk in more details about the skimmers because we have a new skimmer in the market. I mean, we do carry all kinds of skimmers, right? But especially this new skimmer that we came up with. It's a great way to reduce the cost, right? I mean, you're already building a basin and you're adding skimmers, which are not cheap, right? I mean, it could like bigger skimmers like 8 inch and all those could cost you about $7,000 to $8,000. So, we have a skimmer that can actually reduce that cost to half. Like, so it's a great, it's basically what it does is like it's a floating device, right? I mean, over time, when the sediment settles down, right, cleaner water is what is goes out through the outlet structures like skimmers. So this is another great slide, right? I mean, especially in the TCQ, right? We had a little change in 2023, right? When discharging the sediment basin and impoundment, the permeated cell utilize outlet structure that withdraw from the surface. I'm still getting into Oklahoma. It's I just started. I'm doing more research on it. Like I'm trying to see if skimmers are required or not. Like trying to study more. But especially in here Texas, right? I mean, they're implementing most of the cities like Frisco, newer cities like Salina. They require to drain the water from the top by using the skimmers. So what does the skimmer do, right? Basically it floats, right? I mean, over time, you basically they have a dry storage and the wet storage in the pond, right? And then the very top is the clean water. All the sediments are settled down, right? And cleaner water is drained from those skimmer outlet as well. There's different kind of skimmers in the market. We'll talk more. All of them are very good, right? But we'll talk about our skimmers as well in more detail. And just a quick to show you, you see on the very bottom, you can actually put like a gave-in basket. You don't want to drain that very bottom dirty water, right? You want to let it settle down, and that's why we have that little rock at the bottom, about a foot of retention as well. So our first skimmers, like there's different skimmers in the market, right? We have the Faircloth skimmer. We use quite a lot of these in North Texas as well, right? It's one of the grandfather of skimmer. It was invented 25 years ago. One of the oldest in North Carolina as well, right? And then we also have Erosion Supply Company skimmer. We use quite a bit of these as well. You see they have 4 legs at the bottom. What it does is as it goes down, right? Those legs stop from draining those dirty water. Right? And then we have the Reimer Marley skimmer. It's not a great skimmer that we carry. Basically, it does the same thing where it floats in the water, and And then we have this new skimmer that we'll talk in more detail, and actually have a little valve that I'll talk in more detail about it in this slide later. It's actually basically most of the skimmers that you saw in earlier side, it's a constant flow skimmer, but the one we have, storm skimmer is a variable flow skimmer, right? As the depth increases, you see the valve at the bottom, it opens slowly. Well, we have a slide in there, we'll show you more. And then we have the risers, right? Before the skimmers, they were riser structures, right? I mean, they're perforated or a hole at the bottom, like, this is a job you see on the left side. We did a big renewable job in Waco, Texas. And you see that on the very front of the riser, and that's where you connect the down tube of the skimmers as well. They are basically, risers are secondary spillway, or, goes through the skimmers, and then, as it overflows, it goes through the spillway, right? I mean, it goes through the riser, and another big storm, right? It goes through the emergency spillway, which will be our next slide, right? This is another, way to build the emergency spillway. We can use most of the spillway you see are concrete, right? You can also do a little cheaper Fleximat, which is another great product. There's different application that you can use for Fleximat. If you're not familiar, it's one of the great products that we carry in Texas and Oklahoma, and we widely use. We can also use TRM, like turf reinforcement, as well as spillway. It's a great product. Fleximat basically, it's if you don't know, it's a 6.5 inch by 6.5 wide block and 2 inch and a quarter thick. It's cast in a geograde, and it's great. It is one of the most used in different applications. You can use in channel, you can use outlets, landfills, shorelines. I mean, like we talked about the Flexiberm, which is a part of Fleximat as well. This is how a stabilized basin look like, right? I mean, you want the basins to look like this. The inspector is happy when they see stuff like that. You see them on the floor bays. Most of the sediments are settled, right? As you go down, you'll see the baffles, the bay 1, bay 2, bay 3. So this is what the inspector wants, and they come and see, and they'll be very happy. I mean, I like the contractor is following the rules and doing a great job. And this is how, another slide where you see a temporary basin. A lot of people ask, like, does the skimmer stay on forever? Like, I mean, it's technically not like, once the construction is complete and the entire project site is stabilized with vegetation, right? I mean, the skimmer device can be removed and you just plug that bottom in and replace, or either with the permanent outlet structure, you can plug it in. Like my next slide, you can see. Right. This is how the permanent, stormwater basin looks like. I see quite a lot of these in Oklahoma as well. And this is how it's, sometimes like we see common, this is quite common in DFW area. Next would be, now I talked about different components to optimize the sediment, right? Now I'll be talking more about three things, which would be the dimensions, right? I mean, a little bit how to design it, and then I'll talk more about the flocculant. We have a little soil sample here, right, from Howey, Texas. I'll show you how fast this little polymers can settle the sediment quicker. And then we're going to talk about our newest skimmers in the market, storm skimmer, in a little more detail. So before we do that, right, this is a great slide that you see how when the water is entering, right, in the sediment basin and different particles like gravel and big particles like they're rolling and sliding, right? And then you have like some particles like sand and silt and clay, they're jumping up and down. The process is actually called saltation, right? And then you have particles like colloids, right? I mean, which never settles, right? I mean, those particles are always the problem when the neighbors see a dirty pond and and they complain about it. So those are the colloid particles which never settles down, right? And before we talk about how to size the pond and and different, we first need to talk about this. This is the slide we talked earlier, like how different particles settles, right? It's great to know how different particles before we design the sediment basin. So this would be, this is another great NOAA.gov, right? I mean, it's great to, if you go there, right? I mean, you can actually find your 2-year, 24-hour data in there. It's a great tool NOAA has. And just like that, I took a quick example of a rainfall data of 2 cities, right? I mean, it was the Amarillo, Texas, which is the Panhandle. And then I took the Texas, Oklahoma data. And you can see, right? I mean, you see the 2-year, 24-hour event for Amarillo, it's about 2.72 inch, right? Compared to the Tulsa, Oklahoma, it's almost a double, right? Basically, what I'm trying to show in this slide is like, obviously the pond in Oklahoma is, if you disturb 100 acres of in both areas. Obviously, the pond's going to be much bigger compared to Amarillo, Texas, right? So per TCQ or DEQ, right? When data is like no one does cov is not available, or you're just doing a budgetary, right? I mean, you can also use like a simplified this data available 3,600 cubic feet per acre, right? For especially for Oklahoma City or Texas, right? But if you go a little more, arid climate, or it's about 1,800 cubic feet per acre. And then if you go a little bit, north in the tropical climate, which is about 5,400 cubic feet per acre. And basically, what we're doing in here is like, if you take if just over 5 acres of land, right, and if you want to find the volume, what volume is going to flow in that basin, right? 500 acres times 3,600 cubic feet per acre, you're going to have 18,000 cubic feet required volume, right? So it's a great tool, right, to find the volume of the basin. Next would be sediment basin dimensions, right? I mean, when you talk about sediment basin dimension, there's a happy medium, right? I mean, as far as like length width ratios or minimum average depth, or right? I mean, the water is basically coming through a channel and it goes through the turbulent zone where a lot of those bigger particles settles, right? And it goes through the laminar zone. Laminar zone is one of the important zone, right? That's where the most of the sediment settles in there, right? So you want to design a dimension that's perfect. Like you don't want to design like a 1-to-1 or like a 6-to-1 or something like that. What if you have a 6-to-1 or something like that? It'll be I mean, the water's not going to reach on the other side, right? And if you have a little 1-to-1 or like dimension, I mean, the water's going to just I mean, it's just going to rifle through, right? I mean, with higher velocity, right? So the perfect dimension would be like 4-to-1 or 3-to-1, right? As far as the laminar zone is concerned. And the average depth is about 4 feet to 5 feet, right? You see that? It's perfect. You don't want it to be 1 feet because you're going to be draining all the dirty water, right? And you don't want to be too depth because the sediment takes to settle over time, right? So you want a depth about 4 feet, which is perfect, and then you have retention pool of minimum about 1 feet, minimum retention pool. And also this next slide, you see where the skimmers are connected, right? You can actually connect right through that, right below that dirt where the water settles. You can see that where it's connected to the berm, right? You can do that as well. Now we're going to talk about different traditional skimmers, and right. We talked about the dimensions, right? Most of the skimmers you see in this market, right? I mean, they have a fixed orifice size. You see one on the top, East Coast Erosion Supply, and then they all have that common, like, orifice on the top, and, constant flow. And I feel like it's designed for, mostly smaller ponds, right? But everything is bigger in, Texas or Oklahoma, right? I mean, that's why we came up with this new skimmer, a really, really, really good cost-saving skimmer, right? And it's actually a variable flow skimmer. We'll talk in more detail about it. So basically, when you talk about traditional skimmers, right, you have like, basically 6 inch of head pressure, right? So no matter where it floats, like 1 feet, 2 feet, right, wherever it floats in the water, right? I mean, so basically the water is flowing at the same rate for all the skimmers, whether it floats in 1 foot, so it doesn't care, right? But that is fine, right? But everything is bigger, like in Texas or Oklahoma, right? That's why when we design a sediment, like especially TCQ or EPA, or it tells you to design a pond for 2 year 24-hour event, and we have to drain within 2 to 5 days. Some areas in DFW area is about 72 hours, right? Drain time, and basically you have like 3 days to drain it, right? But how does sediment basin work? Sediment basin works by the sediment settle over time, right? But we don't technically we don't have the time because EPA tells us to drain within 3 days, right? Because the reason why we do is the next storm is coming and you want to hold as long as you want, but you have to drain in 72 hours, right? That's how you size the 2-year 24-hour event, right? So that's why I took this example out of Central Texas, North Texas, right? I mean Central Texas in Austin. So basically, if you look at this, right? I mean, in a pond, I mean, theoretically for a 2-year 24-hour event, basically you're saying 1 out of 730 days, right? The pond fills up, right? So there's basically a very low probability of filling the pond, right? I mean, especially in here in DFW area or in Oklahoma area, right? There's always average about like 80 days per year, which is about almost 22% probability of some kind of water in this pond, right? But EPA or they tells you TCQ or DEQ tells you to drain the pond when it gets full in 3 days, right? So based on that, we have to design the skimmer that can drain in the pond in 3 days, right? So that's why this is a great example. You see that, right? I mean, traditional skimmers, right? Constant flow skimmers, you drain, we're looking at a 300,000 cubic feet pond, right? I mean, this example, drain in 3 days, you're telling us to discharge in, 100,000 cubic feet per day, right? It don't matter where the skimmer is at 1 feet, 2 feet, 3 feet, right? So basically, we are doing dirty discharge, blasting a lot of water, even in 6 inch, 7 inches of rain, right? So, so it's kind of unnecessary, right? So that's why we came up with this new product called a storm skimmer. Quick video to show you. Basically, what we are doing is, ordinarily, anybody can see this, right? Usually it'll be in this position when it's when it's very at the very low level, right? I mean 1 feet above the retention pool, right? And as the water level increases and the head pressure increases, it opens slowly. So you can see that, right? I mean, it only drains what is necessary, right? So we'll talk in more detail. Another quick video showing which I made. You can see what's happening inside this is our water quality valves, right? Seeing that it opens and closes as it goes up. Variable flow technology with variable head pressure and variable orifice size. So basically, this is a great, I mean, when we invented this a year ago, right? I mean, we had to take this product to Auburn University to do some, testing. And basically, you see on the right side, which is basically standard orifice equation. I mean, Q is the flow rate, C is the constant, A is the cross-section area of the orifice, G is the gravity, H is head pressure. Basically, using this equation, C is not constant, right? I mean, for soft edge orifice, a common value is 0.61 or 0.62. It's all over the place, right? So basically, it's not constant. So instead of modeling through the orifice equation, we took this to the Auburn University facility and really try to know what the value of C is, right? So that's what we started with the 3-inch valves. I mean, we actually have a 3-inch, 6-inch, and an 8-inch, right? I mean, we tested with the 3-inch orifice and with a 30-degree opening max flow at 4, and it opens those valves open as it goes up, right? In this next slide, you can see as it goes to 4 feet, right? That's where we have our peak flow, right? And as it goes down, it closes. You see the graph, the hydrograph going down, right? That's when it closes down, right? As far as barrel length is always going to be, double the height, right? Basic trig equation. Just like that, we tested our 4-inch valves and we got the same, like, testing, same graph. And then we got the 6-inch, 30-degree, we tested, we got the same thing. And then we tested, you try to choke those and, try to get different points to design for future ponds to model any size of the pond. And we tested with 40% choke, right? So we get this, right? I mean, so it was a great to see this graph and see how our product works, right? So this is a great slide that we're comparing, right? I mean, green is basically, this is where we got our data from the Auburn University. Red it basically a theoretical constant flow skimmers, like different skimmers we talked earlier. And you can see that, right? When we are in 1 feet, like we're talking about 1 feet depth in there, basically we're draining, a traditional skimmer is going to drain at 1 feet. It'll probably be, if you look at the graph, right? I mean, it's about 50,000 cubic feet compared to 10,000, right? Whatever is just needed, right? And when we are at 2 feet, it drains about 50,000 with traditional, and we are about 22,000 cubic feet, right? So, but we have to follow the EPA or DEQ timeframe of 3 days to drain it, right? So basically, as the water depth increases, you can see, like, constant flow has that constant drain, right? Whereas as we go to 4 to 5 feet, we are draining actually more, right? To catch that 3-day time. So basically, if you're draining at 4.5, 5 feet, right, you're basically draining the cleanest water on the top, right? So basically, just like that, we can, we have, you can go to our website, stormskimmer.com, to size the ponds, right? It'll give you a whole data of different stage where, and minute by hour, it'll give you a whole data on it. Another good thing about our skimmer is already pre-assembled. We do it here in North Texas. I mean, whereas compared to other skimmers, you do have to make those on site, and it might take you a couple of hours just to install it inside. Whereas our skimmer comes in 3 components: the head, the floating device, and the down tube, and the valves. It's already pre-assembled, should be shipped to you right away. This is our 6D skimmer, one of our biggest. We use it for 8-inch, especially if you have an 8-inch skimmer, traditional skimmer, you can use this 6D skimmer for that. Quick video showing our storm. We've installed this storm skimmer for, I mean, probably 100 in Texas by now. It's custom built, like I said, right? I mean, we can make it here in North Texas, and then we have this, software right there. You can add all those, like basically you have the project in there, project name, and then you can add the pond sediment basin 1 or 2. You want to add riser or no riser. All you got to add is pond volume, pond top, pond bottom, and it'll basically give you a whole data which you can add in the plans as well. It's great to use. If you need any help using the software in the website, just let me know. I can guide. Okay. So next, our final product is, I'll be really fast on this one because I think I'm over 5 minutes. Will be the floppy lint, right? I mean, floppy lint is basically great We usually have different vendors that make those. We use one of the one we use is the applied polymer system. They make the polychromite flocculant, right? So how does flocculant works is like, so what it does is like, this is a great demo I'm gonna show you, right? Just the dirty water, right here. I'm gonna add one of those polychromite flocculant in there. And just like that in the pond, right? I mean, when it flows, I mean, you add some of these on those channels, right? You can see how fast it's settling, right? Takes about 15 to 30 seconds. What it's doing is, right, I mean, you have those clay soils, right? They have those negative charge, right? So when the reason why you see all this dirt is negative charge when they don't attract, right? So the particles is everywhere and it just floats in the water. So you add this polychromite in there, it has the positive charge, and it joins those negative charge, it forms a flock, bigger flock, and clump it together, and then it settles really quick, like this. See that? In 15 seconds, everything is settled. You see all the dirt down in there. And just like that, we can, use in different applications. And we have this special uh, kit provided by Applied Polymer System. We can actually come help a different engineer or HOA that needs to test their soil. We can come there, me or Tate can come and, we can test and give you the right polymer to use, right? Because these are very expensive, like 50-pound bag is almost like close to $200 to $300. So you want to make sure you want to use the right flocculant, you know. There's different kind. This is one of the most popular flocculant that we use, right? Polychromide. It's a anionic flocculant. There's two kinds. There's the cation and the anionic. Cation is the one you don't want to use, right? Because those are very harmful for the fish. It usually kills the fish. So you want to make sure you want to use the anionic flocculant. Quick slide, it can be used in different wastewater treatment, in industrial food processing, different. In civil application, we want to use the anionic. This is some of the products that does come in. The one I showed you in this form is that silt stock powder form, and we can also, on one on the right side, we also have the flock log, which we can use in a long channel that's flowing through the sediment basin, right? Before it flows through, that you can use that just like the picture on the right side. So there's different applications, right? Treatment solution using this product. What we were talking about earlier. Then we have, cation, which we don't want to use it, right? Like I told earlier, it may require special permit under EPA general permit. And then we have the bentonite based flocculant, which is a little bit cheaper than the other polychromide flocculant. We also have plant-based flocculant as well. This is what we were talking about earlier, the test. We can come and do it for you. Flocculant tailgate test. Quick video. This is a great video to show you, like 10 seconds. You see how fast. One on the right side is where the flocculant is added. How fast the soil settles. Great for sediment basins. Where to apply? You can use apply in some of those channels and ditches, diversion ditches. around pipes or outlets. This is a great slide, showing you want to use in between some wattles so that, it helps to increase the mixing time is very important because you don't want to waste those flocculant. Quick video, you can see how fast as it goes down, right? This dirty water comes out really clean. See on the next slide. As it comes down, all the dirty water is coming out very clean. This is a project we did, right, in Greensboro, North Carolina, where you see there was a lot of complaint about this dirty water, and we treated with this flocculant. It was actually the bentonite flocculant, and with several treatments, like, they had a clean water, within a couple of days. We also have all those powder system and everything. Those were all passive treatment. We also have active treatment system as well, which we it's very expensive, and we don't recommend this, but we do carry that as well. This is all I have for today. I mean, thank you very much. I know I went a little bit longer than 40 minutes. But yeah, all this product that we talked about will help you optimize the sediment basin. Thank you.
Oh, thanks. No, that's great information. And we've got the full hour to finish up some questions. We do have a couple questions if you're ready.
Sure. Great.
Okay, great. Jacob asks, from a cost benefit perspective, what is the most efficient addition to make to a standard sediment addition to make to a standard sediment basin? 4-bay with gabion baskets, floating skimmers, geotextile, coir fiber blankets, intermediate baffles, etc. He goes on to say many times sediment basins used in Oklahoma are only a depressed area with a riser pipe. As we work to improve erosion and sediment control plans, what is the easiest first step, again, from a cost benefit perspective, for improvement to those sediment basin designs?
Definitely those core baffles. I mean, those are not expensive at all. Those are like $500 to $100,000 compared to skimmers. Is a little bit more expensive. Depends on the size of the pond. Like the 1 and 3 inches. I mean, if it's like a 3-inch skimmer, it's about like $1,000, right? And then as you go bigger ponds will require 8-inch, which is about $7,000 to $8,000. But definitely those baffles and 4-bays, it's a very cheap way to do it and install it into. And those will get you almost to 90 to 95%.
Wow. Cool. Thank you. And then Alyssa asks, is there a reason to leave the bottom of a sediment basin, especially a permanent one, bare rather than establishing aquatic vegetation to further slow water entering the basin?
Yeah, I mean, that's what we do. We have dry ponds in here in North Texas, right? So definitely, I mean, yeah, the vegetation is very good, right? So can you repeat the question one more time? Sorry.
Sure. Is there a reason to leave the bottom of a sediment basin, especially a permanent one, bare rather than establishing aquatic vegetation to further slow water entering the basin?
Yeah, definitely. Vegetation is very important. I mean, yes. Instead of leaving it bare, I would recommend, having vegetation at the bottom, right? Which we see it all everywhere in North Texas. It does slow the water down and everything. Yes, ma'am.
Cool. And then we have another question. Wayne asks, can the gabion baskets be removed or reused after the site is stabilized?
Not really, because once you remove those baskets, I mean, it's very hard to put it back in, and usually, well, I mean, those gabions, especially if you have the PVC one, right? You can definitely use it, but why not use Flexiberm where you can reuse again and again, right? It's very easy to remove those Flexiberm compared to gabion baskets. Like, I mean, once you remove, you gotta get all those rocks out. Like it's a tedious process. You can definitely use it if it's a PVC one, galvanized baskets do not last that long. I mean, I see here in North Texas, like, I mean, those baskets go once it gets in the water, right? I mean, it doesn't last but like a couple of years. That's it.
So
Very good.
ultimately, yeah, the gabions can be removed, but they're traditionally gabions are put in more for permanent applications, and designed for sediment runoff, stormwater control. There's cheaper alternatives than
Rock berms, right? Rock
what you
on
can use.
board.
Rock berms. That's exactly what the FlexiBerm product is. There's things are a lot easier for the contractors and specifiers to put in.
Cool. Are there any other questions? I don't see any other questions in chat, but feel free to type those in while we're wrapping up here today. As a reminder, to request a certificate of attendance for today's webinar, be sure to send me an email if you would to request that. And I have posted my email address into chat a couple times. We are having some technical difficulties getting a new person assigned to get being able to upload the YouTube videos, but hopefully we'll get that worked out real soon. So I did post a link to our COSWA YouTube channel there. So we do have other videos already. So if you're interested in learning some more about other things, we have a 3-part flocculant series, amongst other things, including student presentations that are there on our YouTube channel. And I also posted a link to our Sign Up Genius for City of Oklahoma City is having a live flocculant demonstration on April 13th. With Applied Polymer Systems. So if you want to come see that, sign up for that as well. And I don't see any additional questions. Wayne says, good show. Thank you. So good job. Anyway, I'm going to go ahead and stop the recording, and thanks everybody for coming. And if you have any additional questions, feel free to hang out for a couple minutes.